Welcome to today's deep dive. We are jumping into, well, a really fascinating set of sources today.
Yeah, it's definitely a unique one.
Right. So our core material is this single, seemingly obscure blog post from March 13th, 2026. It was written by this guy named Ang.
Who describes himself as an old software plumber.
Exactly, an old software plumber on his personal site, kianmeng.org. And our mission for you today is really twofold.
Right, because on the surface, it's highly technical.
Yeah, so first we're going to extract this brilliant, highly specific technical nugget about, memory optimization and programming.
But we aren't stopping there.
No, we're going to zoom way out. We want to explore the mind of the hyper-productive polymath who actually wrote it, because it turns out how he approaches a single line of code is like a perfect mirror for how he approaches lifelong learning in general.
And honestly, the contrast between his deeply technical code and his broader philosophy, that's what makes this archive so rich.
Oh, absolutely.
Because usually, if you want to learn a complex topic, you just pick up a textbook.
Right.
But textbooks are sanitized. They just show you the polished, final result of someone's expertise.
They don't show the messy middle.
Exactly. Personal chronological journals of tinkering, like these raw daily logs on Ang's blog, they often contain significantly more practical, battle-tested wisdom. You're actually watching the trial and error happen in real time.
It's like finding the secret notebook of a master craftsman,
No.
You might not understand the specific tool he's using right at first glance, but just watching the way his mind approaches a problem, that is an education in itself.
It really is.
So let's look at the specific problem Ang was trying to solve on the afternoon of March 13th.
Okay, let's set the stage.
He was working in a programming language called Haskell, and he was trying to figure out a more efficient way to handle input file validation.
Right, and just to clarify for everyone, Ang was dealing with potentially massive files, and his system needed to check if the text inside those files was properly formatted as UTF-8.
Let's pause there and explain the mechanics of that for a second.
Sure.
Because it sounds really simple on the surface, right? Just checking text. Why is validating UTF-8 such a heavy lift for a computer?
Well, it comes down to how computers actually read characters. So UTF-8 is a variable width character encoding scheme.
Meaning what, exactly?
Meaning a single character like a standard English letter, or maybe a specialized symbol, or even an emoji. It could take anywhere from 1 to 4 bytes of data.
Oh, wow. Okay.
Yeah, so when a computer validates a UTF-8 file, it can't just casually skim it. It actually has to look at the exact sequence of bytes to ensure there are no malformed or legal characters hidden in there.
So it has to read every single bit.
Yes.
Yeah.
And the standard brute force way to do this is to take that massive file and just load the entire thing into the computer's random access memory.
The RAM.
Right, all at once into the RAM, and then scan it.
Which I think everyone listening has probably experienced a version of why that's a terrible idea.
Oh, definitely.
I remember a few years ago, I was trying to open this massive multi-gigabyte CSV database file in a standard spreadsheet software.
Let me guess.
My computer literally sounded like a jet engine taking off. The screen just froze, and eventually the whole program just completely crashed.
Yeah, that crash is basically your operating system panicking.
It felt like a panic.
Because when you force a massive file into active memory, you consume all the available space your computer uses to juggle its current tasks.
Right, the RAM fills up.
And if the RAM fills up completely, the system starts frantically swapping data back and forth to your hard drive, which is painfully slow.
And then it just gives up.
Exactly. It just gives up. So Ang, he wanted to avoid that entire bottleneck. He needed a workaround to validate the file without just swallowing it whole.
And the solution he implemented, which is so cool, relies on this two-step streaming process.
Right.
So step 1 involves a function called BStringLazy.ReadFile.
A very important function name there.
Yeah, and what stands out in his notes is that this function doesn't actually read the file into memory at all. It just points at it.
And that distinction is the key to the whole operation.
Wait, hold on, though. I need to push back on that because conceptually that feels like a total contradiction to me.
How so?
If the computer isn't reading the file, how does it know what's in it to validate it? I'm picturing a computer just staring at the cover of a closed book.
Okay, think of it less like staring at a closed book and more like looking at the library's index card for that book.
Okay, an index card.
The computer basically creates a pointer. It's this tiny, super lightweight reference in its memory that holds the physical address of where that massive file lives on the hard drive.
It's not moving the data.
Exactly. It essentially tells the system, I acknowledge this data exists, and I know exactly where to find it when you are ready, but I am absolutely not going to drag it into our active workspace yet.
So it's a mechanism of deferred execution.
Spot on. Deferred execution.
Okay, that makes so much sense. It sets up the pointer to defer the heavy lifting. And then comes the second step, which is where he uses a module called Data.Text.Lazy.Encoding.
Specifically a function in there called decode of F8 prime.
Right. And because he used that lazy pointer in step 1, this decoding function doesn't try to pull the whole file. It just begins processing on the very first tiny chunk of data.
And the really brilliant part of this specific decode function is its strict error handling.
Yeah.
But it's applied to a lazy stream.
So it begins evaluating the byte sequence chunk by chunk.
Yes.
It's like checking if a gallon of milk has gone bad.
I love this analogy.
Right. You don't need to pour the entire jug into a giant bowl and chug the whole thing to find out if it's spoiled.
That would be horrible.
You just take one tiny sip. And if that first sip is sour, you stop immediately. You just dump it out.
Right. And the computer science term for your sour milk analogy is the fail fast principle.
Fail fast.
Yes, paired directly with lazy evaluation. Instead of doing all the work up front, the system does the absolute minimum amount of work required to get an answer.
So if that function hits a malformed byte in, say, chunk number 2,
It returns a failure result immediately.
it drops the pointer.
It drops the pointer and completely stops. It refuses to waste any computational energy or time processing the remaining gigabytes of that massive file.
You know, taking a step back from Haskell for a second, that is a profound mental model for you to adopt in your daily life.
It really translates everywhere.
We live in a world of absolute data overwhelm. I mean, we are bombarded with massive files of information, super complex projects, endless meetings every single day.
Yeah, the RAM in our brains is constantly maxed out.
Exactly. So learning to evaluate things chunk by chunk and rejecting bad inputs early, I mean, that saves massive amounts of your own mental bandwidth.
Applying lazy evaluation to your own attention span is incredibly effective.
Oh, absolutely.
You don't have to read an entire 400-page book if the first chapter's premise is just fundamentally flawed.
You take one sip.
Right. You evaluate the first chunk, you fail fast, and you preserve your cognitive RAM for something actually useful.
It is the lazy way to be hyper-efficient.
I love that phrasing. The lazy way to be hyper-efficient.
Yeah, by purposefully not doing unnecessary work, Aang's system runs faster and leaner. But, you know, having seen the elegance of how he solves this one hyper-specific technical problem, we kind of have to ask what he actually does with this knowledge.
Right. Does he just lock it away?
Yeah, does he lock it away in his code base and go to sleep? And that brings us to the actual title of this blog post.
Oh, the title is where the true scale of this archive just starts to reveal itself.
Yes.
He titled the post, Notes on Haskell Programming, Part 81.
Part 81. That single post, that beautiful little optimization about lazy evaluation and fail-fast logic, is just one drop in an absolute ocean of documentation.
It really is.
Yeah.
I mean, looking at the sidebar of qianmeng.org gives you a sense of the sheer staggering volume of his output.
It's mind-blowing.
He has been posting consistently since July 2011.
Wow.
This isn't just like a sporadic hobby. It is a relentless daily practice spanning well over a decade.
The stats actually gave me a moment of pure skepticism when I first read them.
I don't blame you.
In 2024, he published 732 posts. In 2025, he published 730 posts.
That is an average of 2 deep, technical, or exploratory posts every single day, year after year.
Right. And just in the first 2.5 months of 2026, leading up to this March 13th post, he had already published 216 posts.
He's a machine.
I have to admit, my initial reaction was to wonder if there is an actual method here, or if this is just some kind of digital hoarding situation.
Like, you just can't stop typing.
Yeah, like how does an old software plumber even have the time to type that much, let alone, you know, do his actual job or live a life outside of a computer screen?
Well, your skepticism is a totally natural reaction to seeing that level of output, but there is absolutely a method behind it.
Okay, what's the secret?
What Aang is demonstrating is a masterclass in a concept called working out loud.
Working out loud.
Yeah, the reason most people struggle to maintain a blog or any kind of public learning journal is that they let perfectionism just completely paralyze them.
Oh, I've been there.
They operate under the assumption that every single post needs to be a definitive, perfectly polished essay that covers a topic comprehensively.
They try to load the entire subject into memory all at once.
That's a great way to frame it, yes. And Aang doesn't do that.
He does the lazy evaluation.
Exactly. He dramatically lowers the friction of publishing by just rawly documenting his incremental progress.
So no polished essays.
Nope. He encounters a problem like massive files bogging down a system. He finds a solution using lazy evaluation. He writes 3 brief paragraphs with a snippet of code. He hits publish, and he moves on.
It is lazy evaluation applied to his own writing process.
It really is.
He's processing his learning chunk by chunk, part 71, part 72, part 81. He doesn't wait until he's the world's foremost authority on Haskell to write the ultimate definitive guide.
No, he just documents the tiny chunk he figured out today.
By lowering the stakes, he maintains an unbelievable momentum.
And for anyone listening who wants to build a body of work or just document their own learning journey, this is the blueprint.
You bypass perfectionism.
Exactly. You bypass it by treating your output as a series of working notes rather than final drafts. You just document the plumbing as you fix the pipes.
But, to maintain an output of 2 posts a day, you eventually run out of server bugs to fix.
You think so, yes.
And this is where the archive gets incredibly fun for me, because Aang isn't just coding. The archive reveals that he takes this exact same hacker, software plumber mindset and applies it directly to the physical world.
The cross-pollination of his interests is just fascinating.
It's wild.
If you scroll through his Notes on series from just the first few weeks of March 2026, he transitions seamlessly from these deep technical discussions on Wi-Fi 7 networking and Python right into agricultural troubleshooting.
The gardening posts are amazing.
They are so detailed.
He's analyzing his leggy seedlings to figure out why they are growing too tall and thin. He's deep diving into his bougainvillea journey, experimenting with flame dwarf cultivars, documenting his Malabar spinach.
And from there, he pivots into human biology, investigating the dietary truths about a lipid medication called icosapent.
And we can't ignore the fish-keeping logs.
The fish keeping is the best part.
The fish-keeping. In the exact same week he is optimizing UTF-8 file validation, he is writing notes on fish-keeping part 206, simulating the monsoon.
Simulating a monsoon.
Where he is figuring out how to adapt specific water parameters for betta fish. I was looking at this thinking, what does a simulated monsoon in a fish tank possibly have in common with streaming file validation in Haskell?
Well, the answer lies in the underlying framework he uses to view the entire world.
Which is?
Systems thinking.
Okay, break that down for us. What does systems thinking actually look like when you move from a laptop to a glass aquarium?
So, at its core, a system is just a set of interconnected parts that produce a specific outcome based on certain inputs.
Right.
Software is just a system of pure logic. But a fish tank is a closed biological and chemical ecosystem.
It's a living system.
Right. And in the wild, betta fish breed during the rainy season. So to simulate a monsoon in a tank, Aang can't just, drop a watering can over the top and call it a day.
Yeah. That won't trick the fish.
No. He has to actually manipulate the inputs of that biological system.
Right.
He systematically drops the water temperature by a few degrees to mimic the cooling effect of rain. He alters the water flow to simulate the physical disturbance of rainfall. He might adjust the pH or the tannin levels using very specific botanical leaves.
So he's reverse engineering the environmental triggers.
He is observing the biological imperative of the fish, tweaking the chemical and physical inputs of the water, observing the outputs, isolating the variables, and making these tiny incremental adjustments until the system functions the way he wants.
Which is exactly what he did with the Haskell code.
Structurally, it is the exact same process as tweaking a lazy pointer to prevent a server from crashing.
That's incredible. A bug in your code and a leggy seedling in your garden are essentially the exact same thing.
They are.
They're both feedback from a complex system telling you that an input needs to change. The plant needs more light and less heat. The software needs a deferred pointer instead of a full memory load.
And Aang's archive proves that deep technical expertise doesn't have to exist in a sterile digital vacuum.
Right.
The analytical mindset of a software plumber is incredibly useful when your actual pipes or your plant roots or your fish tank filters just need attention. He treats the physical world as a system that can be tinkered with and optimized.
And he documents all of this cross-pollination so meticulously. But this relentless sharing of information, I mean, it doesn't happen in a vacuum.
No, not at all.
If you look at the sidebar of qianmeng.org, it becomes very clear that this entire endeavor is driven by a deeply held philosophy about how information should actually be treated.
Yes, you're referring to his do support lists.
Right.
He curates a very specific list of organizations that he champions, including the Electronic Frontier Foundation, the Free Software Foundation, the Software Freedom Conservancy, the Tor Project, and Wikipedia.
And those choices tell us a lot about his core values. He has a massive dedication to FLAHAS.
Free, Libre, and open source software.
Yeah. And the distinction of the word Libre in that acronym that is vital to understanding his mindset.
It really is. Because when people hear free software, they often just think of price, right? Like free as in free beer.
Like $0.
Right. But Libre means free as in free speech.
Oh, that's a great distinction.
It's about user liberty. Organizations like the Free Software Foundation advocate for the right of the user to see the source code, to modify it, to understand how the system works, and to share those modifications.
It's an ethos dedicated to keeping knowledge decentralized and accessible rather than locked behind corporate black boxes.
Exactly.
Which makes total sense given that he openly publishes his daily tinkering. And here is where I notice a really intriguing contrast.
What's that?
He explicitly lists all these open information user freedom organizations that he supports, but right above that list, he slaps a very strict disclaimer on his own site.
Oh, yeah.
He states that his blog is for informational purposes only. He guarantees absolutely nothing about the accuracy of his own logs, and he accepts no liability for how you use the information.
Which sounds harsh at first.
It does. It's almost as if he's saying, here is literally everything I know, poured out for 15 years, given to you completely for free, but you still have to use your own brain before you apply it.
See, that dichotomy isn't a contradiction, though. It is actually the ultimate expression of the open source ethos.
How so?
The philosophy dictates that knowledge should be free, decentralized, and accessible, hence his support for Wikipedia and Tor. Information shouldn't be gatekept.
Right.
However, the application of that knowledge requires personal responsibility.
That is a crucial distinction, because what happens when people don't make that distinction?
Well, you see it all the time on the internet. People treat online tutorials or open source code like a consumer warranty. They blindly copy and paste a block of code into their company's server, or they blindly follow a fish-keeping forum's advice without testing the water, and when the server crashes or the fish gets sick, they blame the author.
They want the freedom of free information without the responsibility of actually understanding it.
They treat learning like a plug-and-play product.
Wow.
But open source doesn't mean guaranteed to work perfectly for your highly specific, unique situation.
Right.
Aang is offering you his tools. He's giving you his raw notes, his mistakes, and his victories. But he is absolutely not taking responsibility for your system.
If you take his Haskell code and it breaks your project, that is on you.
He gives you the tools, but you are the plumber of your own life.
You have to take the information, evaluate it, test it within your own system's variables, and own the outcome.
Yes.
You can't just blindly copy-paste someone else's life advice or code or gardening tips and expect it to run flawlessly if you haven't put in the work to understand the underlying mechanics yourself.
And taking ownership of the variables in your own life, that is the defining characteristic of someone who actually learns, rather than someone who just mimics.
That is perfectly said. So, bringing all of this together for you as we wrap up today's deep dive, Aang's massive, sprawling blog shows us that being a true learner isn't about knowing everything perfectly before you speak.
Not at all.
It isn't about writing the definitive, polished textbook. It's about continuous, fearless tinkering.
It's about looking at the complex systems all around you, whether they are massive data files bogging down your computer, or lady seedlings struggling on a windowsill, or a simulated monsoon in an aquarium and figuring out how they work, just one small chunk at a time.
Chunk by chunk.
And crucially, having the humility to just write down what you learned today without worrying if it is some kind of masterpiece.
Absolutely. So we want to leave you with a final thought to mull over, something you can explore on your own that really builds on this incredible source material.
Something to tinker with.
Exactly. Think way back to the beginning of our conversation today, back to Aang's lazy Haskell code. The code that evaluates data chunk by chunk, takes one tiny sip of the milk and relies on that fail-fast principle to stop processing the exact second it detects a fatal error.
Such a powerful concept.
What if you applied that exact same fail-fast, lazy evaluation to the media, the news, and the information you consume every single day?
Ooh, I like where this is going.
If you stopped processing a source the moment its underlying logic proved unreliable or toxic, instead of, hate reading the entire article or sitting through the whole exhausting broadcast just to see how it ends, how much of your own mental RAM could you actually save?
A lot.
If you drop the pointer on bad data early, how much bandwidth could you free up for the things that actually help your own system grow? Keep tinkering, stay curious, and we will catch you on the next deep dive.